Hi, welcome to the presentation on using aluminum flocculants to treat stormwater ponds to control phosphorus in the city of Verona. This presentation was originally given on October 5th, 2021, and this is an updated version of that. You'll see in the presentation that there's some new information that became available with some sampling results, which is why this is an updated presentation. We'll go through the big picture of stormwater management, why we do what we do, why we want to consider treating ponds, and why the ponds that we chose were treated in particular. We'll give you some details of those ponds when we did the work. We'll talk about how that worked. We'll talk about the test data that came out of it using ACH, which is aluminum chlorhydrate, versus aluminum, which are two different flocculants. We'll talk about cost, give you a quick summary, and what's next. And at the end, I've got a little bit of information that I will flash through on this particular presentation, but not spend a lot of time verbalizing for those of you who want to take a deeper dive into the chemistry of the treatment. So Verona is part of the Mississippi River watershed. We're located in the upper Sugar River watershed. The Sugar River drains down into the Pecatonica into the Rock, and the Rock River flows into the Mississippi in northern Illinois along the western edge of the state. So we are a contributor to this watershed. I point that out because every spring, summer, and fall, there is a zone of water in the Gulf of Mexico that has so much basically pollution coming into it that all of the dissolved oxygen is used up, and a hypoxic or dead zone forms and basically is unable to sustain life. So this is an expression of the pollution that this one half to two-thirds of the continental US delivers to the Gulf of Mexico. So this is why we do what we do. We're part of trying to address a nationwide problem. Verona has more than 30 stormwater basins, wet stormwater basins, about 60 total basins. We can store about 115 million gallons of water in our stormwater basins currently. Why treat ponds? Runoff water transports nutrients. Stormwater ponds can get overloaded with nutrients, and algae blooms result, which is an unpleasant situation. The ponds are meant to settle out these nutrients, but sometimes that settling is not fast enough, which to prevent the blooming from occurring. So we have a desire to have cleaner discharge water, and you'll be seeing some information on standards as we go through this. And we look at phosphorus as the key limiting nutrient. So if we can take phosphorus out of the equation of nutrients, it will limit the amount of algae that can grow. When there's excess phosphorus, algae can really take off in a stormwater pond. We chose 3 ponds to treat in 2021. They are the Silent Street Pond, which was cleaned out in December of 2018, the Meister Edition West Pond, which was cleaned out in July of 2019, and the American Way Pond in the Verona Technology Park, which was originally treated in a demonstration project in May of 2019. So we had reasons to want to go back to these ponds to do additional work on them. the pond numbers are part of the inventory of stormwater ponds. So you'll see those along with it, and that's just a part of our way of identifying these ponds. So Silent Street and Meister had sediment removed. We estimated some phosphorus removal from each of those based on concentration of phosphorus in the sediments that we had analyzed and the amount of sediment that we did. Basically, a pretty straightforward mass balance type of calculation. So we estimate we pulled out about 3,270 pounds of phosphorus from the sediment in Silent Street Pond. We estimate we pulled out about 785 pounds of phosphorus from the Meister Pond. Significance of that is the potential exists for this phosphorus in these sediments to be resuspended. So taking that out was a benefit to the environment, as well as a benefit for maintaining the ponds themselves. The American Way Pond, we stripped about 10 pounds of phosphorus out of the water, and that is coming from what was the concentration before we did the treatment to what was the concentration immediately afterwards. And then we also estimated that in 2019, we deactivated an additional 286 pounds of phosphorus. And that's based on the amount of aluminum that was applied in the flocculant to the ponds, and using about 10% of that. It comes from the equilibrium chemistry, and we use the 10% because aluminum is reacting with many other things besides phosphorus in that stormwater. So, and this just comes purely from experience of other users. So in 2021, we were doing a continuation of the initial trial of 2019. We had some slightly different goals. In 2019, we just wanted to take out as much phosphorus from the American Way Pond as we possibly could. In 2021, we wanted to take out some phosphorus, but the idea was to enhance the development of the deactivation layer of the sediment, and I'll get into that a little bit more in just a little bit on the rest of the presentation. In 2021, we used alum, which is, and in 2019, we used aluminum chlorhydrate. So alum is aluminum sulfate, and ACH is aluminum chlorhydrate. They have different pros and cons. This treatment is a possible tool should at some point stricter regulations come down on the Sugar River. So for the treatment in 2021, the background information on each of the ponds. Silent Street Pond is about 1.3 acres, holds about 1.49 million gallons of water, has a drainage shed of about 121 acres. Phosphorus concentrations were measured on several occasions. Through 2020, we had a range of 341 to 561. When we did pre-treatment analysis, that phosphorus level had dropped down to 132, and that was the basis for our dose calculations. Comparing all of those numbers to our water quality standard of 75 micrograms per liter of phosphorus for waters of the state of Wisconsin. Here's a map of the Silent Street Pond. It is at the intersection of Silent Street and Enterprise Drive, across the Enterprise from the Verona Library. It's part of a park. There's some and people like to come and sit alongside the pond, but no active recreation at this time. Here's the drainage area for Silent Street Pond. It's the fully visible area, and Silent Street is part of a network of ponds that ultimately drain to the Badger Mill Creek. So there's another 2 or 3 ponds that are upstream of Silent Street Pond. Meister Pond is nearly the same size as Silent Street, about 1.4 acres, but holds a little bit less water, mostly because it's a shallower pond, and the drainage area, the drainage shed is about 44 acres. Phosphorus concentrations higher when we did our pre-dose testing at 215, but through 2020, generally on the lower end. And again, that water quality standard of 75. Meister Pond is a long rectangular pond on the edge of Verona. We've got Breckenridge Drive alongside of it, Meister Park up to the north, and off to the west is the initial campus of the medical software company Epic. You're seeing their parking lot with their solar panels there. Here's the drainage shed for a Meister Pond. Virtually all residential land use within that, with the exception of the park and obviously the streets. American Way Pond is our largest pond in the city of Verona, stormwater pond. About 20 million gallons of water, about 175 acres of drainage shed with a plan to add an additional 205 acres. Pre-treatment phosphorus at 61 micrograms varied between 60 and 84 during the 2020 monitoring, and again, that water quality standard of 75. Here's the American Way Pond. It's a more interesting pond. It's got an island in the middle. It's also it's deeper than our typical ponds at an average depth of about 7 to 8 feet. Wisconsin Brewing Company sits on the pond and often takes advantage of the view of the pond for its tasting room and outdoor services area. So it is a much appreciated pond. It's in an industrial park, American Way and Thousand Oaks Trail. Here's that drainage shed, virtually all industrial park with a portion of a state park to the south that actually also contributes, though obviously most of that is undeveloped runoff. Treatment was completed on all 3 of these ponds in May of 2021. We were able to get all 3 done in one day. Here we are treating the Silent Street Pond with the Verona Library in the background. Our contractor was ERD out of the Orlando, Florida area. These guys also did our demonstration project back in 2019. So we're very comfortable working with them and have a lot of confidence in their ability to put the right amount of flocculant in, depending upon what we're using for the given situation. They come highly equipped with good instrumentation to monitor what they're doing as they're applying it. And we were using alum in this case, which is much more sensitive to pH, and they did a really good job of making sure we didn't put too much of that in the water. Here we are treating the Meister Pond with the houses in the background. And then finally, the American Way Pond, where we put the majority of the flocculant in on that particular day. Well, how did it work? For Silent Street and Meister, the results were not as dramatic as the American Way Pond. We did reduce phosphorus and we did reduce chlorophyll A. Ultimately, I'll get into Meister Pond. We did probably initially stir up more sediment because of the shallow depth and actually raised phosphorus levels slightly after pre-treatment than before, but then they settle back down. The water clarity in Meister, because it was so shallow, may have facilitated more emergent vegetation. American Way, we had very dramatic and positive results. We had clarity almost the entire 8 feet. There was less foaming on the water using the alum than the ACH when we did that in 2019. So let's look at some results. Here are test results from before and after, and then our basically mid-spring, midsummer, early fall testing on these waters. So Silent Street, we tested on May 18th before treatment, 423, May 21st after treatment, 265, so pretty nice drop. And then throughout the course of the summer, an up-down phosphorus level. So mid-June or early June, the phosphorus levels were up. August, they went up again, and then in October, those numbers came down. Meister, here's that increase. So we started off at 63.9, bumped up to 68.9, but then dropped back down to 45, and then up and up again in August and October. American Way Pond test results before treatment 97.9, dropped down to 14.7. So this is that strip number, excuse me, let me go back. This is that strip number, the difference between the before concentration and the after. That's when I speak of stripped out, that's what I'm talking about. Then you'll see that American Way went up, and then had a little drop down in October. These were our sampling results for those ponds the year before. We did sampling on a number of ponds, but these 3 in particular. And you can see somewhat of a similar pattern for Silent Street, increase from June to August and then decrease in October. Meister had a little bit of a different program, decrease from June to August, but then a major increase in October of 2020. I don't have a good explanation for that, but that's what the data showed. American Way, we had just a continual, relatively gradual increase. So this was October of 2020, we were at 83.7, and if you'll recall, at the beginning of May before treatment, we were up at 97. So chemical component of the long-term reasons for doing the treatment. So the settle flock continues to react as over time to a stable state, and that's this mineralization project where its ultimate endpoint is gibbsite. The phosphorus that's locked up in these flocculants are prevented from being resuspended. So those are the 2-3 good things that are going on with this flocculation after you've done the treatment. And then the sediment continues to pull a small amount of phosphorus from the water until it reaches the endpoint of its capacity. And that's what we're talking about with this deactivation layer, or this notion of deactivation of phosphorus. So we did some projections, and this is based on the dosing that we did in the ponds. We initially projected some phosphorus stripping out of each of the ponds. We calculated that stripping based on those before and after concentrations. Here's Meister with that slight increase. My hypothesis is that we stirred up sediment in that pond that caused that to happen. And then here's what we deactivated about it. And these deactivation, stripping and deactivation are all about the amount of aluminum that we put into the pond. So this table is showing the relationship of the gallons of alum that we put in, the amount of aluminum, the stripping ratio, the stripped phosphorus, the amount deactivated. So the total amount of phosphorus that we've taken out of circulation in each one of these ponds. So I'll get to the lesson a little bit more. Obviously, Silent Street and Meister, we did not take a lot of phosphorus out of those ponds. Considerably smaller ponds compared to American Way. So some food for thought there. Now I'm going to talk a little bit about the differences and the pros and cons of using alum versus ACH. So in this case, we wanted to set up that deactivation layer, and alum has a longer pathway to the gibbsite endpoint than ACH, which is why we chose to use it in this case. I was interested in trying to develop that, especially in these ponds where we've cleaned out the pond and we know that that sediment's going to sit there for a longer period of time. The cost of the chemicals and bringing in the contractor for all three of these together were $22,469. That's not counting city time for doing the project management, but just pure outlay costs for the city. Total of about 124 pounds of phosphorus deactivated at about $181 per pound of phosphorus, which was similar to what we calculated during our demonstration project in 2019. So in summary, we did achieve P removal. The costs were the same as 2019 demonstration project where we actually used ACH, and starting to come back around to thinking that ACH may be more suited for these shallower ponds because you just cannot get that much alum into the water due to the constraints of the changes of pH. ACH does not have that same change. So if we were to do this again, I would probably look at doing ACH on any of our smaller ponds because we would get much more phosphorus removal. The caveat that I do have is if I were to go back and do Meister Pond again, because it's so shallow, I really want to think about really how clear do I want that water because of the problem of emergent vegetation. Silent Street is a deeper pond, so we don't have that same issue with the emergence coming through from the bottom. So we'll continue to sample these ponds as we did through 2021, hopefully into 2022. I would say it would be important to evaluate our sediments and take a look at that deactivation layer and how we're doing. And my contractor that did the application is versed in this, so we're going to be looking into doing that in 2022, and plan to do some subsequent treatment in the next few years. The idea, at least right now, is that we would do treatment after we do cleanouts. We've got one major cleanout on the horizon. It's the Prairie Oaks Basin. I did a presentation on that on September 21st, 2021, just to explain that one. That happens to be our second largest pond. And then consider a mix of alum and ACH as we go forward. Again, I think for these smaller ponds, I would lean towards ACH rather than alum. For the bigger ponds, I might want to look at alum because of the possibility of getting that deactivation layer and a little bit longer life that alum is going to have in the pond before the capacity to continue to absorb phosphorus is used up. I would just like to make an acknowledgement to some people that I've really learned a lot over the past 3-4 years on working on this business of treating ponds. Harvey Harper from Environmental Research and Design was the company that did our treatment and who I've been working with on our pre-treatment dosing and considering to work with on analyzing our sediments. Harry Gibbons is a consultant that works out of the Seattle, Washington area. I had the opportunity to take a course of his back in 2019, learning about alum treatment in lakes and getting some concepts. And that's really where I learned about this concept of deactivation. I'd like to thank Richard Weddapole, a former Wisconsin Department of Natural Resource employee who initially brought this idea of treating the American Way Pond to me, and who was a big participant in helping to make that project happen and put Verona down a path that is, I think, ahead of a lot of other communities in terms of trying to look at what's going on with stormwater and how we might manage that. And then finally, I've got to acknowledge my Director of Public Works, my boss, Theron Jacobson. Without his support, I wouldn't have the opportunity to be involved in projects like this. Normally, if this was a live presentation, this would be the time for questions. I'm gonna click through some technical slides after this. I won't say a whole lot. For those of you who are interested in a little bit more detail on the chemistry behind flocculation. So here we go. The flocculation is a series of hydrolysis reactions. Here's what it looks like for alum. Here's that aging process as alum ages and ultimately ends up as gibbsite, that mineral content, which is very stable with that locked in phosphorus inside of these matrices. And then here's a little bit more of that definition. Your alum is going to be less expensive, but it also contains less aluminum. Aluminum chlorhydrate on a per gallon basis is going to be more expensive, but you're getting considerably more aluminum in content in that. And then for these smaller ponds, I think that's why we want to go with ACH, because you'll get a better bang for your buck for the cost of doing the treatment, because a significant portion of it is going to be tied up in your contractor. There's some information on how aluminum sulfate is made and some of that chemical reaction information and why it affects pH a little bit more. And then that's information on aluminum chlorhydrate. With that, I'm going to end the presentation, and thank you very much for listening in. I hope you enjoyed it. Check out some of the other presentations at the Verona Library website on stormwater management issues. Have a great day.